Global Green Solutions Incorporated, publicly traded under symbol GGRN on the U.S. OTC Bulletin Board, has developed Greensteam, a patent-pending biomass to renewable energy technology for industrial heating purposes and cogenerating electrical power. Biomass disposal is a growing problem. Converting biomass into energy is an obvious answer, but the average biomass to energy plant in the United States is 30 years old and can't cope with increasingly strict air emission rules. We project the revolutionary Greensteam process is 20% more efficient than any current biomass combustion technology, will produce 80% less air emissions, and will be recognized as U.S. EPA Best Available Control Technology for air emissions from biomass. Greensteam may also be the only technology capable of meeting new, even more stringent EPA air emission standards for biomass combustion. The Greensteam process consists of a receiving, storage, and fuel preparation system, 1 to 10 Greensteam advanced biomass energy conversion units, and a steam turbine generator if electricity is required. One Greensteam advanced biomass energy conversion unit produces enough energy to heat 20,000 average American homes. Global Green Solutions has successfully completed initial testing of the Greensteam process at its 1/4 scale demonstration plant located in Era Energy LLC's oil field near Bakersfield, California. Era Energy, one of California's largest oil and gas producers and owned by affiliates of ExxonMobil and Shell, provided substantial funding for the $9 million plant. Greensteam biomass fuel comes from forest, lumber, and paper mill residues, clean municipal solid waste, and agricultural and food processing residuals like the byproduct shown here leaving a food processing plant. By using this otherwise waste as fuel, Greensteam could make this plant completely independent from fossil fuels and electricity from the local grid. At the Bakersfield demonstration project, woody agricultural residues similar in size and texture to the food processing byproduct we just looked at is delivered by truck to the receiving system, where it proceeds automatically through the plant until it is converted into energy. It is first transferred via conveyor to the screening and sizing process, where undesirable material is removed and all fuel is sized to uniform dimensions. The still moist fuel is conveyed up to the top of the dryer. The dryer, operating on waste heat, is a rotating drum with internal fins which carry the fuel to the top and allow it to fall to the bottom. A stream of hot gas conveys the fuel along the length of the dryer. Each time the fuel is carried to the top and falls to the bottom, it moves closer to the dryer exit, where it is blown out after reaching the low moisture content required for efficient combustion. The dry fuel is then conveyed to the final sizing operation. A hatch cover on the line is removed here so you can see the fuel being conveyed. The final sizing operation pulverizes the fuel until it's the consistency of dry pencil shavings, perfect for combustion. The dry fuel particles are then stored in a silo which holds enough fuel for multiple hours of operation, helping ensure the reliability Greensteam customers need. The quantity of dry fuel removed from the storage silo and conveyed to the Greensteam suspension combustor is precisely controlled. We have again removed the cover to allow you to see the finely granulated material leaving the weigh scale and headed for the suspension combustor. The suspension combustor and heat recovery steam generator are proprietary to Greensteam. Together with the dryer, they comprise the Advanced Biomass Energy Conversion Unit, the heart of Greensteam's uniqueness and source of intellectual property. Here we are looking inside the suspension combustor through a viewport. The video was shot when the unit was operating at full capacity and producing steam which was supplied to Era Energy for enhanced oil recovery. What you are seeing is the near instantaneous combustion of dry fuel particles blown into the combustion chamber. The specially designed Greensteam combustor allows operation at very high temperatures, causing complete, clean combustion, reducing emissions of carbon monoxide, particulate matter, organic compounds, and other products of incomplete combustion. With better combustion, excess air can be reduced. improving efficiency just like closing the damper on your fireplace does. In addition, Greensteam precisely mixes dry, solid fuel, air, and recirculated flue gas to produce ultra-low NOx emissions. Reaching this technology demonstration milestone is incredibly important for us and a big step toward full commercialization. Witnessing Greensteam in operation after 4 years of development is exciting for our team, our investors, and our project partners.